All right, in this video, we'll be looking at blood vessels yet again, hence the part two. And we'll be looking at capillaries specifically and then veins after that. So let's talk about these things. So here's some capillaries, just capillaries in general before we get into capillary specific. So capillaries in general, these are microscopic blood vessels. The diameters of many of them are so small that only a single red blood cell can pass through at a time. And so when we say microscopic, literally you can't see them without a microscope. The walls have this thin tunica intima, so that innermost layer there of the blood vessels. And typically, as you can see here, they're just one cell thick. And so very, very small. There are other types of cells here. I don't see it on this. There it is, pericytes. And these pericytes are like stem cells to help to stabilize the capillary walls. And they play obviously a very important role in vessel repair because they represent stem cells being able to make new types of cells. They supply, so capillaries supply almost every single cell in the body, which is just incredible if you think about it, except for some of the places like cartilage and your epidermis and a couple other places like your cornea and your eyes doesn't have any blood flow. The lens of the eye doesn't have any blood flow. Some of the cartilage in the like meniscus and that sort of thing, not a lot of blood flow, but everything else in the body is supplied by these capillaries, literally every single cell. And so their function is to exchange gases, to get rid of CO2, to take in oxygen, to get rid of waste, to deliver hormones. There's a lot of things these capillaries are doing. Like I said, they're the business end of the circulatory system. So there are three types of capillaries that you need to be able to look at. Well, one more thing before I go into three types. All of these cells are joined together by these tight junctions. Remember, the tight junctions are between cells, and it's almost like stitching. So it's like quilting between the two cells. So it's very, very strong joint. It allows the passage of fluids and stuff like that in between them, but not a whole lot else. So three types of capillaries. The first type are this continuous capillary. They are abundant in skin. They're abundant in muscles, lungs, central nervous system. Probably the most common type of the most common type of capillary. Also the least permeable, so it's harder for things to get in and out of these. The next one is called the fenestrated capillary, and the word fenestrate or fenestrations are like pores, and so these have lots of permeability. And these are going to be in areas that there's going to be filtration, kind of like the kidneys or the intestines. I'm saying all the things that you can just read here, but I still want to say them. And you can see that they have this kind of, like it says here, this Swiss cheese kind of arrangement. And this allows for materials to get in and out. This allows for absorption of nutrients or anything else into and out of the bloodstream. And then the last type of capillary are called sinusoid capillary. And as you can see, this is a lot looser. Anytime you see this sinus, it means just a cavity. And so these are going to create these bigger sections of blood. Usually have the holes in them or the fenestrations like the fenestrated, but they have these larger clefts in between the two cells, these kind of spaces in between. They're found in the liver, they're found in the bone marrow, and some other areas. Blood flow is typically slower in these capillaries because it allows time for molecules to be doing their work. It allows time for there to be more blood flow in these types of areas. And also they contain macrophages, which saying you see that right here. They basically a macrophage is little immune system cells that go through and eat things that are not supposed to be there. And so this is what, there's a lot more blood in these capillaries than in the other capillaries. So it gives it time to kind of do the work of that area. And then there are these sections called capillary beds. Now, a capillary bed is just a bunch of capillaries. That's the easiest way to think about it. But more specific definition is kind of this interwoven network of capillaries between the arterioles, and then the small veins, the venules, which we haven't talked about. And so it's kind of like, if you can think of our region, if you were going to get from 641 to, I don't know, Purchase Parkway, and obviously they connect over there in Benton, but there's other ways to get there. You could take all these little back roads to get there, and you would still make the same trip. And so think of those back roads as being like the capillary beds connecting the two larger veins or two larger blood vessels. And so this is where all of that circulation is going on. All these, think of like when you cut your finger and it bleeds, you have pricked one of those capillary beds that represented in your finger. And so this is just the connection between veins and arteries. Speaking of veins, here they are. Veins carry blood toward the heart, and they have a much different kind of makeup than arteries. Whereas arteries have to sustain pressure, veins are more of like holding facilities as that blood slowly makes its way back to the heart, relatively slowly compared to the artery. The arteries are more like a speedy highway. The veins are kind of like a slow moving train coming back to the heart. All right. And so as the blood leaves the capillary beds and it goes through these tiny little veins, it slowly builds up to where you have these giant kinds of veins building up. I have this picture to show you, and I'll go back to the other one because I like that one too. So here's the venules. These are smaller veins. Their partner would be like the arterioles on the other side. No elastic tissues at all. Very little smooth muscle. And so the capillaries are basically uniting. Think of little small streams uniting to make a bigger stream. That's kind of like what's going on here. Very porous, and so they allow fluids from the white blood cells to come into the tissues as well. And so this is where a lot of immune system functions is happening as well. And then the larger venules are moving into, as more and more of these venules converge, you have what are just called a straight up vein. All right. They have all those tunics that we saw, those media intima and externa, but as you can see, the elastic tissues and the small or the smooth muscle are very small compared to an artery, as you can see in this one. So this very small layers compared to these very thick and pronounced layers in the artery. And because of this, the veins end up storing most of the body's blood as it kind of slowly moves its way back to the heart. 60 to 65% of the body's blood is in veins at any time. And if you think about it, if you're standing, for instance, I stand all day as a teacher, there's blood in my veins, in my legs. My legs are probably half my body's mass. And so they're slowly making its way back up. Well, in order to do that, in order to prevent backflow and not all the blood being in my feet, veins also have valves, just like the heart does, that prevent the backflow. And they're, of course, most abundantly found in your limbs, your arms and your legs. And they also have, I don't have a picture of this, which I did. Some veins have these flattened sections that are called venous sinuses. Again, their sinuses represents a cavity. And so there's a large section of blood that's kind of being housed. You see these sinuses sometimes around organs and so forth. And flattened, they're kind of flat veins with very thin walls. And again, just has to do with blood storage. And so the blood is slowly making its way back to the heart, and it does this in these veins. And as you can see, it's not in the arteries very much at all, or in the capillaries very much at all. It's slowly making its way constantly back to the heart and then pumped out really quickly once it gets to the heart. And we'll talk in a future video about that whole track that blood makes through the body.